Newton's first law is that an object will remain at rest or move at a constant speed in a straight line unless acted upon by an unbalanced force. In the first example, I'm going to use the tumble track to show a balanced force. In the second example, my shoulder is going to act as the unbalanced force, causing a change in direction. For an example of inertia, I'm going to run at that mat and try to knock it down. The more speed I have, the more inertia I have, and the less ability the mat has to stop me, because I'll be hitting it harder. Now that I've hit the mat, I'm at rest because I've been stopped by it. Both these objects have the same amount of air resistance, but because one is lighter and has less mass, the air resistance is going to have more effect on it, and it's going to fall slower. On this bar, there isn't any friction, so this slides freely. If you weren't strapped in, you would come right off the bar because you wouldn't be able to hold on. Because now I'm strapped in and the bar still moves freely, it allows me to do gymnastics without any friction on the bar, so I can move around the bar faster. Grips, my hands have friction on the bar, so when I put them on the bar, the chalk creates a good grip, but that also slows down my speed around the bar. The second law is stating that the more force you apply to the object, the greater the acceleration will be. So I'm going to push this mat first at a walking speed with small force and then running with heavy force, and when I push it harder it will go faster. Now I'm going to increase my force to increase the speed. Now I'm going to use a little mat and push it. With the same amount of force I use on the bigger mat, the little mat will go faster than it did because it is less to push. Newton's third law states that for every action, there's an opposite reaction. So when you hit the trampoline with a tight force, you balance. Demonstrate Newton's third law by showing that for the amount of force you apply to the trampoline, you get the same amount of reaction in return.
Got it.
I'm going to start by showing you a small amount of force and the small bounce you get when you use a small amount of force. I'm only applying a little force to the trampoline. Now I'm going to use a greater amount of force, so because the action's greater, the reaction is also going to be greater too.